Let's talk about fine tuning. So, we just finished this topic as part of the AI engineer course, and I'll just talk to some of the core concepts and some really cool things that we learned on the topic of fine tuning. So, in particular, with our example, we actually taught a chatbot model, Llama 3.23 billion parameter, how to think and reason step by step. So if we take a quick look at this diagram here, um, you'll see kind of the core problem that we set ourselves to solve. So traditionally, if you wanted to teach AI to solve math problems, you used supervised fine tuning. You had to provide thousands of expensive human written examples showing exactly how to solve the problem step by step. And then the AI would simply learn to mimic the human. And you can see that here on the right. However, we used a different approach in this workbook that I'll show you later. We use GRPO, so that stands for Group Relative Policy Optimization. And it's actually the same reinforcement learning algorithm behind DeepSeek R1. So we in GRPO, we didn't actually show the model any reasoning examples. Instead, we fed it a prompt, let it generate 8 different attempts, and used automated code to check if the final math answer was right. And essentially, it's learning through trial and error. And so we can see that here on the left hand side. But it sounds quite computationally expensive. And so how did we do it on a single GPU? In particular, I used TPU T4 on Colab, but I'll break down kind of how we were able to do it so resource efficiently. So if you take a look at this diagram, you'll see standard fine tuning. We're actually, when we do that, we're updating all 3.2 billion parameters, and that requires a massive amount of VRAM. So to solve this, we did LoRa fine tuning or low rank adaptation, where we essentially completely freeze the original 16-bit weights of the model so they never change. And then we attach 2 tiny trainable matrices. So there we have our frozen and our trainable matrices. And during the training, we only update these tiny matrices, which represents less than 3% of the total model. And this kept our memory footprint incredibly small while allowing us to run Unsloth's fast inference engine for maximum text generation speed. And so with this method of freezing kind of the bulk of it and only having a small matrices off to the side that we actually train, we're able to not use as much compute resources. So let's take a quick look at the GRPO algorithm and see how the model essentially learned. So this is the GRPO training loop that we see here. We start with, we used JSM 8K, so it's like a bunch of math problems. And so we start with essentially a grade school math prompt. Our model generates a group of 8 different completions, and then these completions are passed Here we see the completions are passed to our automated reward function, where they're essentially evaluated, and we grade them and then spit out 8 different scores. And so you can see that here we get 8 different scores at the end. And from here, this is where GRPO really kicks in and is kind of genius, I would say. It calculates an average of the 8 scores, so a group average. And if completion 1 scored higher than the group average, well then it gets a positive advantage. And with that, our LoRa weights are updated, and essentially we encourage that behavior. So we update our LoRa weights and then it runs again. So if completion 2 scored below average, it's penalized, and this essentially keeps it to a self-contained evolutionary loop where the model constantly tries to beat its own average, which is pretty cool. And then quickly just understanding that reward stack and how things work. So this is essentially with the reward function, we're essentially teaching it how to think and So early in the training, you can imagine the model doesn't know how to do any maths whatsoever. So it's essentially getting every question wrong. And if we only rewarded it for correct maths, the score would always be 0, and it would essentially never learn. And so to fix this, we built a gradient to climb, so a stack of partial credits, where we want the model to start to use reasoning brackets and then answer XML tags to format its thoughts. And at the bottom of the stack, if the model accidentally generated a single piece of an XML tag, we gave it a 0.125 reward. If it puts the tags in the right order, it gets 0.5 points. If it makes the answer an integer, so the format rules, we give it another 0.5 points. So pretty much essentially how you would have been graded throughout high school, where you get points for showing your working and so on. And the model quickly learns to chase these formatting points to beat its group average. And by learning the format, it builds a structured scratch pad. And once it has a scratch pad to think of, it eventually pieces together the maths, and will then eventually get the right answer. And when it gets the right maths answer, it gets a massive positive reward of +2. And this is essentially it hitting the jackpot, and then it begins to understand kind of the winning strategy. So we did this, and we went through it all in this workbook here, and you can see all the training runs and so on. It was quite interesting to see and actually work through, and understanding the kind of reward mechanisms you want to use for your given scenario. And so with maths, it's very verifiable on kind of a final answer, and also that kind of availability of that training set that you have really helps as well. And so here we can see kind of the the format that we wanted it to start to think in and build up its scratch pad to work off. Yeah, and building that reward function. And so, yeah, continuing on, we can see the train versus reward graph here across all the steps as it trains. And here we have kind of that big training run that happened, the rewarding, kind of giving it those soft rewards to start off with, and so on. And so you can see here we did over, wow, quite a lot of runs, 175 runs. And then, yeah, it was able to essentially build up and solve problems. And so here we see it answer the question, calculate pi, and eventually it got to the point where, it's got its reasoning tag and comes up with a formula to calculate pi, and then a final answer with a lot of digits of pi. All in all, it was a great exercise to go through, and I hope you learned something. Thanks for watching.